The diagram shows a cube without any label of the measurement of the length, right? Nothing. Our task is to calculate the angle between the diagonal AP, the line AP, and also the base ABCD. Before we get into the calculation part, it's best if we could identify which is the angle between the line AP and also the plane ABCD. Now the angle that we're dealing with, it must be in between AP and ABCD. So you look for the common letters. In this case is letter A. So this letter will be in between. And since it came from the line AP, so P will be included. So it is angle PA. With the last letter, it could be PAB, PAC, or PAD. So which angle could it be? So how do we decide on that based on this letter? So if you look at letter P compared to PC, PB, and PD, which is the shortest distance from P to point CBD? Which one is the shortest distance? Obviously, PC is the shortest distance to plane ABCD. That's why the angle will be angle PAC. That is the angle in between diagonal AP and also the plane ABCD. This is how we decide. So we are finding or looking for angle PAC. However, there is none of the length of the is given. So we do not know any of the length. So we can assign as an unknown. So the best thing that we will include will be x as the length of the cube. And since we know that cube have the same length throughout for all the lengths, if you could imagine, if we are finding angle PAC, so this is the one that we're looking into, theta. This is angle PAC. So do we know the length of PC? We do not, but we label it as the unknown x. In order to find this angle theta, we need to figure out either the length of PA or the length of PC. So which one is easier? So no, not PC, sorry. AP or AC? AC is here, AP is here. I think it's easier to find AC. Then after that you could find AP. So I think AC will be enough, more than enough. Let's look into the length of AC. How do you find AC? Then you can look into another triangle, which is triangle ABC. So the base. So from the base, oopsie. Okay, from the base, we have a right angle triangle of ABC. Does not look like a triangle, right angle triangle. Okay, what is this? Okay, we have A, B, C. Whereas everyone agreed that PC is the same length as BC, same length as AB, since it's a cube. Right? So we have BC being X and AB being X. So our task is to find AC so that we can use it over here. Okay, to find AC is a right angle triangle, so we could apply Pythagoras theorem. It will be C square equals to A square plus B square. So in this case, to find AC, it will be a square root of x square plus x square, and that will be square root of 2x square. That will be square root of 2x. So that's the length of AC. Okay, so we could use it here. So we could put square root 2 over x. Okay, now we have more than enough information to find theta. Okay, same, referring to the same right angle triangle. So we can use SOHCAHTOA, right? If you remember SOHCAHTOA. Okay, this is the angle. Opposite of this angle will be labeled as O. This will be A. And opposite of 90 degree will be H. So we have the information about O and A, hence we go for T, tangent. Tangent theta equals to O, which is x, A, which is A sub 2, x. If you could simplify it, cut off the x, it'll be 1 over sub 2. There you go. Since this is a calculator paper, we could use inverse of tangent of 1 over sub 2. Okay, where's my calculator? Okay, tangent inverse. For those who are watching this, you can try out as well. If you have tangent inverse of 1 over root 2, what would that be in terms of tangent? Yeah. So make sure that your calculator for the angle input, it is tangent, yeah. If it's radian, if it's not radian, then it will be wrong, right? Okay, so from the calculator, what do you get? So from the calculator, you get 35.2644, and you round it off to 3 significant figure. 35, oh no, for angle is 1 decimal place. So 35.3 degree. Yep, that's the answer.